Hello everyone. So today we will learn about Taylor series lab 12. Okay. Um, lab 11 is due tonight, so make sure you submit your assignments on time. Now coming to the lab 12, we have 4 types of questions. The first type is you need to find the Taylor series using the Taylor series formula. And in the second type, you need to use the Maclaurin series and then integrate to find the series of the following problems. And for the third type, you will be doing similar to type 2, but instead of integrating one, here you will have 2 equations. So you need to find the Maclaurin series for the left and right hand side equation. Okay. Now in the last type, you will have to find the interval of convergence for the following power series. So remember, we did this in lab 11, right? We did the same problems, similar problems. Okay, so today I will pick one problem from here, one from here. I will be skipping third type because it is similar to type 1. So instead of Taylor series formula, you have to use the Maclaurin series formula. Okay. Now in the fourth type, I will be doing one problem on this as well. Okay. So let's get started. Example number 1. We have f of x equal to, before this, let me write the formula for the Taylor series first. Summation n equal to 0 to infinity fn into e into x minus a to the power of n divided by n factorial. So here n, which is f to the power of n. So this n is not actually like f square or f cube. It is actually f double prime, f triple prime, like this. That is the number of times you are differentiating the function. Okay. Do not get confused with the symbol there. So in a similar way, we also define Maclaurin series. So this actually is a special type of Taylor series. So if we plug in a equal to 0, the series which we obtain is called as Maclaurin series. Okay. So this is fn of 0. X minus 0 is x to the power of n. So I will write that directly, divided by n factorial. So we will be using both these formulas to solve the following problems. Let us start with example number 1, f of x equal to e to the power of x, and you need to find the Taylor series at a point a equal to 3. Okay, now using the formula given here, we have summation n equal to 0 to infinity fn nth derivative of a at point a x minus a to the power of n divided by n factorial. Okay, now plug in the value given here for a. So we get summation n equal to 0 to infinity fn of 3 x minus 3 to the power of n divided by n factorial. Okay, now we need to find what is the nth derivative of the given function. So in order to do that, let us first find the first derivative, that is f prime of x dy by dx that is nothing but e to the power of x. So derivative of e to the power of x is e to the power of x. Okay. Now f double prime of x will give us d by dx of again e to the power of x, which is nothing but e to the power of x. Okay. So if you keep on finding the derivative, the nth derivative is nothing but dn of dx to the power of n of ex is nothing but the function itself. Okay. Now we need to find what is fn of 3, right? Instead of x, just plug in 3, you get e to the power of 3. Okay. Now you will plug in whatever you have got here equal to summation n equal to 0 to infinity. Fn of 3 is e to the power of 3 into x minus 3 to the power of n divided by n factorial. Okay. So finally, you can write the series in this form. So you can just bring the exponential outside the summation because it doesn't depend on the term n. So you can keep the rest of the terms inside the summation. Okay. So this is your final answer. Okay. Now let us move on to example number 2. So we will here also we will use the Taylor series to solve f of x equal to minus sine of 2x, and we have to find the series at a point of negative pi by 4. Okay. Now when we use Taylor series, we need to find what is fn of x, right? So let us do that first. So f prime of x is nothing but negative 2 cos of 2x, right? Sine of 2x is nothing but cos 2x, but you also have to apply chain rule because you have 2x inside the sine function. So that will give us 2. Then what is f double prime of x? That will be equal to 4 times cos of 2x. Okay, and if you find f triple prime of x, you get 8 cos of 2x. Sorry, this is sine. So we get alternative sine, cos, sine, cos. And if you do that further, I will write it as 4 of x. You get negative 16 sine of 2x. Okay. Now, if you find values at a point a equal to negative pi by 4, then we get f prime of negative pi by 4 will be equal to negative 2 times cos of 2 pi by 4. Negative 2 pi by 4. So this is nothing but 0. Okay. So if you do that for f double prime, negative pi by 4, you get 0. Oops, I'm sorry, again, this is 2 to the power of 0. Now f triple prime, second. 1 second, there is a small correction here. Before writing f prime, I have to write what is the value of f first. So f of negative pi by 4, that has to come first. That is negative sine of pi by 2, right? So sine of pi by 2 is 0. Sine of negative so this will give us this will give me 2 to the power of 0. That is nothing but 1. So let me write 1. Okay, now for f prime at negative pi by 4, we will get 0 because cos 90 is 0. And then we get f double prime of negative pi by 4. That will be equal to negative 4. So you can also write this as negative 2 square if you want to. And then we have f triple prime of negative pi by 4. That is equal to 0 again. And f fourth prime of negative pi by 4. That is equal to 16. We can write this in terms of 2 power as 2 to the power of 4. So here we actually have 2 to the power of 0. And then we have 2 to the power of 2 and then 2 to the power of 4. And in the alternative terms, we have 0. Okay. Remember, we need to find the patterns first so that we can develop the series later. Okay. Now, use the summation formula, Taylor series formula, 0 to infinity, fn. Now, I did not find the nth derivative because the given function is a trigonometric. So if you find the derivative, it just keeps on alternating between sine and cos. Okay. So instead of finding the nth derivative, we can do in this way as well. So the point A is negative pi by 4 of x minus a. So minus pi by 4, when you add that, you get positive to the power of n divided by n factorial. Now let us expand the series. Let me write this here. So this is equal to f of x plus f prime of x plus f double prime of x divided by 0 factorial, 1 factorial, 2 factorial, plus so on. Okay, so we are going to plug in all the values which we got here. So we got for f of x, we got 1, right? So we can write 1 as 2 to the power of 0, x plus pi by 4 to the power of 0, because n is 0, divided by 0 factorial, plus, what was f prime of x we got? 0, right? So f prime was 0, I will write that as it is, plus f double prime of pi by 4 is 2 square, x plus pi by 4, here n is equal to 2, this is for n equal to 0, n equal to 1, n equal to 2, plus, oh, do not forget to write the factorial, plus again 0. So this is f of x. This term which we have here is f of x. And then we have f prime of x. And we have f double prime, f triple prime. And next we will be having f to the power of 4th prime. So that is given by 2 to the power of 4, x plus pi by 4 to the power of 4 divided by 4 factorial. Okay, plus so on. Now, as you can see here, we can actually eliminate the alternative terms, right? And the first term is actually the power of 2, or the powers of 2. And the next term which you see here, x plus pi by 4, is actually to the power of n. So there is no change here. Okay. So using this pattern, we will find the series. We can write this as summation n equal to 1 to infinity. That's because this is anyhow 0, right? This is anyhow 0. So let us start from n equal to 1 instead of n equal to 0. So n equal to 1 to infinity. Since we have only positive terms, we can actually take it as negative 1 to the power of n minus 1. Okay, into, since we have to the power of 0, powers of 2, we can write in this way, 2 to the power of 2n minus 2. Okay, into x plus pi by 4 to the power of 2n minus 2 whole divided by 2n minus 2 the whole factorial. Okay, so why did I get 2n minus 2? That's because if you observe here carefully, for n equal to 0, we got to the power of 0. That's fine. But for here, this is for n equal to 1 and n equal to 2. Now, if you plug in the same n equal to 0 and 0, 1, and 2 here, you have to get back the same series. Okay, and that's the reason we write 2n minus 2. Or you can also write it as, you can write 2n minus 2 as 2 to the power of 2 outside and n minus 1 inside. You can write in this way as well. Okay, so this is for a trigonometric function. I think you have to write from here. Now let us move on to example number 3. F of x equal to integral e to the power of negative x squared dx. Now we will be using Maclaurin series here. So they have not mentioned the a value because we have to know that when we have this type of series, a is always equal to 0. Okay, now I can use the formula above, and I can write e to the power of negative x squared equal to summation n equal to 0 to infinity. Since we have a equal to 0, I get only x, negative x square to the power of n divided by n factorial. Okay, now if you expand the following series, we get for n equal to 0, we get 1, right? Minus x square divided by 1 factorial plus x to the power of 4 divided by 2 factorial plus negative x to the power of 6 divided by 3 factorial plus x to the power of 8 divided by 4 factorial, and so on. Okay, now in order to find the integral of this function, we need to find the integral of all these series which we have mentioned just now, of this entire series. Okay, dx. Now let us integrate the following series. So integral of 1 is x minus x cubed divided by 3 factorial plus x to the power of 5 divided by 5 times 2. So 10 factorial minus x to the power of 7 divided by 7 times 3 factorial plus x to the power of 9 divided by 9 times 4 factorial minus so on. Now, not to forget, we need to add the constant as well. Okay. Now we can develop this as a series, and we can write a summation n equal to 0 to infinity negative 1 to the power of n x to the power of 2n plus 1 divided by 2n plus 1 into n the whole factorial. So this is by using the Maclaurin series. Okay, now let us move on to the last example. So here we need to find the interval of convergence of the given power series. We did the same thing in lab 11. So I am just going to brush upon that. So let us take summation n equal to 1 to infinity x minus 3 to the power of n plus 1 whole divided by n square minus n plus 1. Okay, now we can use the ratio test here as an plus 1 divided by an. that is equal to x minus 3 to the power of n plus 2 divided by n plus 1 the whole square minus n plus 1 plus 1. Okay, just plug in n plus 1 wherever you have n. And then you're going to multiply the denominator that is given by an. That is n square minus n plus 1 divided by x minus 3 to the power of n plus 1. Now you can actually divide these two, x minus 3 and x minus 3. And then you get x minus 3 will be to the power of 1 is the remaining term. And you have n square minus n plus 1. Here, if you simplify the denominator, you get back n plus 1 the whole square minus n. Now simplifying the entire terms, you get n square minus n plus 1 divided by n plus 1 the whole square minus n. And we have x minus 3 inside the absolute function. Now, as n tends to infinity, the following series, it will reduce to x minus 3. Okay, so this entire term will give you, this entire term will give you 1 as n tends to infinity. Okay, now in order for this to converge, we have to have x minus 3 less than 1 according to ratio test, right? Now, in order to find the values for x, you can actually remove the absolute sign. Then you get x between -1 and +1. So to find the x value, you can add 3 on either side. So -3 plus 3 is 2. So here we have the interval of convergence, but you must also find what happens at x equal to 2 and what happens at x equal to 4. Okay, I will leave these two for you. You need to find whether plug in x equal to 2 in the original series. Okay, and then check whether that series is going to converge or diverge. This is going to converge or diverge. So if it is converging, then you have to include 2 and 4 in the interval as well. Okay, now, so interval of convergence is x less than 2 and 4, or is it including 2 and 4? Okay, you have to decide between these two. In order to find which option, you need to check whether what is happening at x equal to 2 and 4. Okay, so I will leave the last work to you. So this will complete lab 12. So we also have lab 13. Okay, so we will be meeting next week. So if you have any questions, you can stay on Zoom. If not, we'll be meeting next week for the last lab. Okay.